All right, let's just jump right in. We live on a blue planet, right? A world that is literally covered in water. And yet, all we hear about is a global water crisis. It's a huge paradox. So in this explainer, we're going to break down that very paradox and take a look at the incredible tech being built to solve our planet's growing thirst.
You've probably heard this line before. It's from an old poem, but honestly, it perfectly captures the heart of our problem. The issue isn't a lack of water on Earth, it's a lack of the right kind of water. And that all comes down to the numbers.
And this is the big one. A truly staggering 97% of all the water on our planet is salt water. It's sitting in our vast oceans. You can't drink it, you can't use it to grow food. It's just off limits to us, unless we use some pretty serious technology.
Okay, so what about that tiny little 2.5% that's left over? You know, the fresh water. Well, it turns out most of it is surprisingly hard to get to. Nearly 70% of it is just frozen solid in glaciers and ice caps. And another 30%? That's groundwater, buried deep, deep beneath our feet, which is often really difficult and slow to access.
So when you do all the math, it comes down to this absolutely wild number, less than 1%. Less than 1% of all the water on Earth is easily accessible fresh water in our lakes and rivers. That tiny, tiny sliver is what has to support all 8 billion of us for drinking, farming, industry, you name it, the whole shebang.
Now that fragile supply was already stretched pretty thin, but now several major forces are putting it under some really unprecedented pressure, and that's what's accelerating this crisis.
It's really a perfect storm. I mean, our population is booming, which means we need more water for people and for the food they eat. At the same time, our cities are exploding, straining old infrastructure. And in a lot of places, that infrastructure is leaky or just totally mismanaged, wasting the little water we do have. But the biggest accelerator of all? Yeah, that's climate change.
And you can see here how climate change is attacking our water supply from all these different angles. It's not just one thing. Higher temperatures mean more of our surface water is literally vanishing into thin air through evaporation. It's causing more frequent and severe droughts while also, paradoxically, leading to extreme floods that can contaminate the clean water we actually do have. It's completely disrupting the water cycle we've relied on for, well, forever. So, with our freshwater supply under so much stress, humanity is turning to the most obvious and, let's be honest, the most ambitious solution out there. Tapping into that other 97%. So let's talk about making the ocean drinkable.
The tech that does this is called desalination. And at its core, it's a really simple idea. You take salty water, you get the salt out, and what you're left with is pure, fresh water. So how does it actually work? Well, there are two main ways we do it.
The old school method is thermal desalination. You basically boil the seawater, collect the steam, which is pure H2O, and then you condense it back into liquid. The modern method, and the one you see most often today, is reverse osmosis. Think of it like a super, super fine filter. You use a ton of pressure to force seawater through a special membrane that's so fine only the tiny water molecules can squeeze through, leaving all the salt and other gunk behind.
And this is what makes desalination so powerful, right? It effectively creates a brand new source of water out of thin air, or, well, out of the ocean. For arid, coastal places like Israel or Saudi Arabia, it's an absolute lifeline. It creates a water supply that's completely independent of unpredictable rain, giving them real water security. But, and this is a big but, it is not a silver bullet. The process, especially reverse osmosis, needs a huge amount of energy to run. These plants cost billions to build and operate. And then you have to deal with the waste product, this super salty sludge called brine, which can seriously harm marine ecosystems if you don't dispose of it very, very carefully.
So if desalination is the big brute force approach, what are the more elegant solutions?
Well, these are all about being smarter with the water that we already have.
Okay, this one is a total game changer. Water reuse, sometimes it's called water recycling, basically takes the wastewater from our sinks, our showers, our industries, treats it to an incredibly high standard, and puts it right back to work. It literally turns waste into a valuable, local, renewable resource.
But there's a catch, and it's not a technical one. It's all in our heads. It's the yuck factor. The idea of drinking water that was once, in a toilet, that's a tough sell for a lot of people. And that's true even though the treated water is often purer than what comes out of a traditional tap. Places like Singapore have really proven that public education is just as important as the engineering.
The other elegant solution is to just stop wasting so much water in the first place. I mean, some cities lose 30% or more of their water just from leaky pipes. Smart water systems are the answer here. It's like upgrading the entire city's plumbing with the brain, using sensors and AI to spot leaks the second they happen and manage the whole system with incredible precision.
So, to put it all together, you've got water reuse, which focuses on recycling wastewater to create a new supply, but it has to fight that public perception problem. And then you have smart water systems, which focus on efficiency to prevent losing the water we already have, but they do require a pretty big upfront investment in tech.
So those are the big solutions that are in play today. But you know technology, it never stands still. So let's take a quick look at the really cutting-edge innovations that are just over the horizon.
The future here is incredibly exciting. Researchers are developing graphene membranes that could make desalination way more energy efficient. They're pairing desalination plants directly with solar and wind farms to make them totally sustainable. And get this, we're even seeing technology that can literally pull water out of thin air, using advanced materials that act like super sponges even in the driest deserts on Earth.
So after all that, what does this all mean? Well, the most important thing is to stop looking for that one single magic fix, because it doesn't exist. Instead, we really need to think of all these technologies as a diverse toolbox.
And this really brings it all home. Desalination is perfect for a dry coastal city. Water reuse is ideal for a dense urban area that's looking to be more self-sufficient. And smart systems, they're absolutely essential for any city with aging infrastructure. The right solution depends completely on the local situation. There's no one-size-fits-all answer.
If you remember just 3 things from this explainer, make it these. First off, these technologies work best together. They complement each other, they don't compete. Second, just having the tech isn't enough. We have to make it cheap, scalable, and sustainable. And finally, never ever underestimate the human element. Convincing people to trust and adopt these new systems, well, that's half the battle.
Which leaves us with this final thought. The science is there. The engineering is there. We have the tools. So the real question isn't can we solve the water crisis anymore? It's how will we? With what combination of technology, investment, and public will are we going to choose to build a more water-secure future for everyone?